live now. I imagine our participants are going to be able to start joining us. And we're now streaming on YouTube as well. Excellent. Excellent.
Fantastic.
Everything looks great. Thank you, Michelle. Hi, everyone. Welcome. People are starting to join us. We're going to get going in just another minute. We've got some great speakers here with us today. We're so glad to have all of you here on this lovely day. How's the weather out where you are? How about our JPL folks, Gregory and CJ? How's the weather out where you guys are?
Well, it's sunny as usual, but it's a little chilly for LA, but absolutely beautiful.
Right. It's really hard to complain when you live in Southern California, weather-wise, of course.
It never rains in Southern California.
Not often enough. Not often enough.
And Ari, how's the weather where you are?
It's beautiful here in Denver. No snow inside. I think we're in the high 50s today. Beautiful winter day.
Awesome. Awesome. And Alan, how would you describe the weather here in Houston?
Well, it's a lot like what Ari described. We're sort of in the high 50s, low 60s. I'm looking out the window at a pale blue sky with puffy white clouds. It's just gorgeous. I'd rather be outside, actually.
Welcome, everyone. So we're going to begin in just one more minute, and you are all welcome to enter things in the chat. Lacey in Texas here, 85 and beautiful, and Lisa from Charleston, South Carolina. And Lisa, you're a solar system ambassador. Can you tell us what the weather's like over there? And Nicole, Honolulu. Boy, it must be awesome. And Patricia, you're proud of CJ being here with us. We are delighted to have all of our speakers here with us today. It's raining in Hawaii. I'm so sorry, but in a few moments it won't be, right? In Hawaii. So, as people are starting to join, we are going to let you know a little bit more about the session in a minute. We've got about an hour and a half to chat with our marvelous speakers and get questions answered by them. They're going to tell us a little bit more about their careers and about the mission and their work. And so we're so glad to have them and you with us. You will have time to ask your questions. If the chat gets busy, I recommend entering your questions in the Q&A section instead, so that way we don't lose them, because otherwise we might have trouble keeping an eye on the questions in the Q&A session. And we've already got one. Someone wants to know what the weather's like on Mars at the landing zone. Alan, I see you're typing an answer. Do you want to also say something?
Sure, yeah. The weather on Mars is almost always clear and cold. I don't actually know if it's nighttime or not at Jesuit right now, but there's very rarely any clouds to speak of. There's some dust in the air. You might see some really high cirrus clouds, and high temperatures might get up to freezing, to 0 Celsius, or might not in the summer.
Awesome. Awesome. Thank you, Alan. So yeah, not exactly Hawaii, not balmy there. We're going to have plenty of time for all of your questions, and I'll be asking lots of questions of our speakers as well. I'd like everyone to please use the Q&A to ask questions, so we can keep an eye on those so we don't lose them. All of you are welcome to share your thoughts and ideas with each other in the chat box. Please select all participants and panelists, or all attendees and panelists, if you want all of the attendees to also see what you're typing. So that way you get the chance to share with each other as well. And this session is being recorded, and it's also being streamed. We are streaming on YouTube, and maybe we can put in the chat box that YouTube channel for anyone who wants to know a little bit more about that. Excellent. So here you can see the YouTube channel. If your friends want to join you and they can't get in, have them joined by YouTube. If anyone is having any difficulty with audio, please join by phone instead if you're having some audio troubles. And my name is Christine Shupla. I'm from the Lunar and Planetary Institute, and we are just so delighted to have all of you here. We are going to limit our attendees' microphones and cameras because there's going to be a lot of you and we want to be able to focus on our panelists. So you are not being enabled to share your cameras or your microphones, and that's intentional. But we do want to hear from you. We do want you to enter things in the chat and in the questions. We will also be having polling questions throughout, and we would love your participation in that as well. So Michelle, could you please bring up poll number 4? Tell us about yourself. Poll number 4 for us. And we're going to ask all of those who are with us right now to share some information about themselves. There's in poll number 4. And while we're working on that, here we are. So we'd like all of you, and this is multiple choice, you can enter multiple things. Have you heard someone talk about Mars before? Have you met a NASA scientist or an engineer before? And that includes NASA-funded scientists and engineers. Are you really interested in space science? Have you heard a scientist or an engineer talk about their work before? Do you plan on watching the Mars 2020 landing? And are you interested in becoming a scientist, an engineer, or a technician? Or are you already one? Please go ahead and vote. Let us know a little bit more about yourselves. And we're going to give you 10 seconds to finish voting. Everyone, you've got 10 seconds, 9 seconds, 8, 7, 6, 5, 4, 3, 2, 1. And let's go ahead and close that out and let's share the answers. Let's see what everyone said. So we have quite a few have heard someone talk about Mars before. And we've got, a little bit of everything here. A lot of you plan on watching the Mars 2020 landing. Thank you so much, Michelle. You can go ahead and close that out. And I am going to stop talking for a few minutes and let our leaders tell you a little bit more about today. So next slide. Amanda, you're up.
Hi, good morning or afternoon, depending on where you are. My name is Amanda Smith Hackler, and I'm the Director of Education for the University Space Research Association, or USRA. USRA's mission is to advance space and aeronautics-related exploration through innovative research, technology, and education programs, including the STEM Action Center. The STEM Action Center is intended to serve K-12 students in Maryland and beyond, and we offer an array of programming intended to strengthen interest and retention in STEM degree and career fields. Today we have an exciting program plan featuring some of the most eminent subject matter experts supporting the Perseverance landing. But first, I'd like to make you aware of a few upcoming events. So mark your calendars. First, on Saturday, February 13th, Dr. Candace Bedford will deliver a virtual presentation focused on the Perseverance landing. So this event is free, but registration is required. Then on February the 17th, in collaboration with the American Museum of Natural History, we'll be hosting an interactive and immersive online program featuring astronauts Mary Cleave, Alvin Drew, and Paul Richards. So please visit stemaction.usra.edu for more information on each of these exciting events. Michelle, I'll turn it over to you now.
Thank you, Amanda. I just wanted to give a big shout out and thank you to our presenting sponsor, Lockheed Martin. We appreciate their support in helping us not only host this panel, but our educational workshop that Amanda mentioned and our next 2 events. So I want to thank Lockheed Martin for their support. Christine?
Thank you, Michelle. So we're glad to have 4 very exciting speakers with us today. And before we actually go through our 4 speakers, I would like to add another poll question. So Michelle, can we please bring up poll number 1 about the trip to Mars? Because we're going to ask each of our speakers to go ahead and talk a little bit about this as well. So for everyone who's with us, if you could take a trip to Mars in person, yourself, physically, would you go to Mars? You've got several choices here. Absolutely, definitely not, probably, but I need to think about it. Probably not. I have no idea. We're going to give you 5 seconds to finish answering. 5, 4, 3, 2, 1. And let's see what everybody answered. Let's see. A number of you, about half of you said absolutely, and about 20% of you said no, and everyone else is sort of in between. Thank you so much, Michelle. So we have several speakers here. Ari, let's go ahead and start with you. Michelle, let's move to the next slide. Ari Vogel from Lockheed Martin, could you please tell us a tiny bit about yourself and what you do and whether or not you would go to Mars if you had the opportunity?
Sure thing. Thanks, Christine. Before I hop in, I just want to thank the USRA for this awesome opportunity. Anytime that we can get out and have a conversation with future engineers and scientists, it's an awesome opportunity, and we really hope that out of this we can inspire and energize the future generations that will be working in our fields in space. So as Christine mentioned, my name is Ari Vogel. Some of the other panelists may disagree, but I have the coolest job in the world. I get to lead our deep space exploration market segment at Lockheed Martin. Our team has had a hand in and a role in the exploration, the robotic exploration of every single planet in our solar system. We've done a lot on Mars. We've been fortunate enough to be involved in 22 total Mars missions, all of NASA's Mars missions in one way or the other. And it's a really exciting opportunity to do that and to continue to expand our knowledge, humankind's knowledge of the universe. Really excited for February 18th and looking forward to what the rest of the panel has to say. In terms of whether I'd go to Mars or not, I have great respect for our astronauts. For the sacrifices they make, both training and leading up to their missions. A mission to Mars, if I could take my family, I would be there in a heartbeat. I'm not sure I have it in me to sacrifice leaving my wife and 2 sons and dog for a multi-year mission. But I'm very thankful we do have people who are willing to do that.
Thank you so much, Ari. So CJ, you're up. Please introduce yourself, what you do, and please also let us know whether you would, in fact, take a trip to Mars if you had the opportunity to do so.
Sure thing. Thanks, Christine. Hi, everybody. My name is CJ Giovinco. I use they, them pronouns. I work at the Jet Propulsion Laboratory as a systems engineer on the entry, descent, and landing team of the Mars 2020 mission. So we're the team responsible for delivering Perseverance to the surface of Mars and making sure it's put down nice and gentle and ready for surface operations. My role on the team is at landing as the activity lead. So it's my job to walk through the procedure in the last 6 to 8 days prior to landing to make sure Perseverance is in the right state and is healthy and is ready for landing. And prior to that, the last few years, I've spent designing, testing, verifying the system that we've built, as well as working on our backup flight software, which is what we call Second Chance. As for whether I would go to Mars, I'm pretty similar to Ari. If I could go with my family, then I would absolutely go. I'm not a big fan of roller coasters. They turn my stomach. So if we could figure that out, that'd be real helpful. But I would love the opportunity to just be out in space and to put boots down on another planet would be pretty cool.
Thank you. Awesome. Lovely. Lovely. And so do you agree that Ari has the coolest job, or do you think you have the no?
I think Gregory and I might tie for coolest job, but I think it's awesome that we all love what we do so much.
I agree. I agree. All right. Thank you, CJ. Gregory, thank you so much for joining us. Please tell everybody a little bit about yourself, what you do, and whether or not you would go to Mars if you could.
Hi, everyone. Hi, Christine. Thanks for having me today. I like to describe my job as, I'm just a kid in an adult body living my dream job. I've been working at JPL for the past 12 years and very fortunately over 2 Mars missions. So I'm really just here for the ride, living my dream, helping people like CJ do what they need to do to get their job done. But I also work on the entry, descent, and landing team. And I basically, just fill in any roles that people need to get done when there's tests that need to be done or analysis that need to be done, I kind of shepherd those efforts along and make sure they get done on time. In terms of going to Mars, that answer kind of fluctuated for me throughout my life cycle. In my earlier years, I was all about going to Mars and like, let's just go to space. But I think I share the same sentiment as CJ, where, now in life, I'm just a little more, I like to enjoy Earth more. And maybe that answer might change as I get older and, maybe I would like to retire or die on Mars one day. But, this really changed when the movie The Martian came out, because, seeing Matt Damon go to Mars really inspired me to go again. But I guess we'll see how things end up in the next few years.
Thank you, Gregory. Awesome. And Alan, please tell us all a little bit about yourself and whether or not you would go to Mars.
Yeah, I'm Alan. I'm a scientist. I'm a geologist, meaning I work on rocks mostly. I started off as a rock collector as a kid. That was what my dad took us out and we loved to do. And I can hardly imagine that I've lived my life being paid to do something I really enjoy doing. So don't tell anybody that they're doing that. I've been involved in Mars for several years now. With the MSL mission, which I'm involved in right now. On Mars 2020, I'm part of one of the science teams for the PIXL instrument that you'll hear more about, measures chemical compositions of samples, and also on the return sample team, where I help make good decisions about which samples are actually going to come back. I don't know, I think I have the coolest job. I guess all of the jobs involved here are really cool. As far as going to Mars, I would definitely do that. My focus is on Mars itself, and it is just so frustrating to see our rover, even as wonderful it is, go up to rocks and not be able to turn it over, pick it up in their hand, or for me to be able to just turn it in real time and take my hand lens and look at it. So I would definitely go in a heartbeat. I have to have someone take care of the cat in the meantime, but I would definitely go.
Awesome. Lovely. Thank you, Alan. So, folks, for all of you joining us, we're going to ask another poll question now. You're asking us questions and we will get to them, I promise. And so our panelists can start taking a look at those as well. But let's go ahead and let's bring up the poll question about the trip to Mars. So, Michelle, can you please bring up poll number 1? Yeah, not that one. I'm sorry. Poll number two. I'm sorry. How long will it take to get to Mars? How long will it take the Mars 2020 mission with the Perseverance rover to reach Mars? That one. Thank you. So, folks, we've got 2 questions here. So instead of just giving you 5 seconds, we'll give you 8 seconds to answer. How long will it take the Mars 2020 mission to reach Mars? And how long does it take a spacecraft in comparison to reach the moon? So we're going to have 8 seconds, 7, 6, 5, 4, 3, 2, 1. What did everybody answer? Let's go ahead and pull up the answers. Yay! Great job, folks. You have the right answers. Good job. About 7 months for Mars 2020 and about 3 days to reach the moon in comparison. So thank you for that. And before we move on to the next slide, I see that one of our questions that we've received was, when is Perseverance going to land? And Sherelle has answered that, but I'm going to let some of our panelists also say something about that. Who wants to jump in and talk a little bit more about when it left and when it's landing?
I guess I could take that.
That would be great, Gregory.
Yeah. So about almost 7 months ago, we launched Perseverance from the Cape in Florida. I think it was like July 30th, I believe. And now I think we're, like a little under 2 weeks away from getting to Mars. So Perseverance will be entering the atmosphere on February 18. So everybody tune into that. I believe the show starts at 11:30 Pacific.
Awesome. Wonderful. Thank you. So, and I'm just going to remind everyone that I'm keeping my eye on the Q&A section. So if you wouldn't mind entering your questions in the Q&A section instead of in the chat, that way we don't miss anyone's important questions. That would be wonderful. And also, if you want the others who are joining us to see your comments, please enter them to all panelists and attendees so everyone can be participating in the discussion. That would be great. So we've got a number of images that we've asked our panelists wants to provide us with that we're going to be asking them to speak a little bit about, as well as while we're answering some of the questions that are on here. So Ari, I wanted to ask you to share a little bit about this picture. And while you're doing that, also tell us a little bit more about what the most exciting thing in terms of what you've done or learned while working on this mission has been. What's the most exciting part of working on the Mars 2020 mission for you? And please tell us a little bit more about this picture.
All right, great. I'll start off with the picture itself. So prior to having the coolest job in the world, I had another really fun job. I got to various different positions on a U.S. Space Force communication satellite called Advanced Extremely High Frequency, or Advanced EHF. That embedded picture is a picture of me with the 4th out of 6 Advanced EHF vehicles prior to shipping it off to the launch site for launch. Many different jobs within this program, everything from systems engineering to subcontracts to systems engineering, integration and test, to ground flight software, to integration and test and launch operations. So really a full gambit of different roles within just the same program. And the picture there on the bottom is my customer, Lieutenant Colonel Latour, who was with my boss, Mike Cachero, and we had this cool idea during Advanced EHF 6 launch, where we were walking away from the launch vehicle with our satellite safely encapsulated in the top. And that launch was at the end of March of 2020, so right as the pandemic was really becoming real to a lot of people. So it was definitely a trying time in my career, but also one that's very memorable. In terms of M2020, Mars 2020, and the Perseverance mission, I will admit I am a newbie to my position. I just started this role in deep space exploration in September of 2020. So me personally, I didn't get a lot of, I don't have a lot of cool personal stories. I will say that Lockheed Martin was responsible for providing the aeroshell, which is the heat shield in the back shell that safely transports the Perseverance lander and Ingenuity helicopter on its 7-month cruise and helps it from, or keeps it from burning up upon entry of the Martian atmosphere. So very proud of Lockheed Martin's role there. Unfortunately, nothing more personal than that at this point.
So, Ari, have you been to many launches then in general?
Yeah, I was fortunate enough to be a part of 4 out of the 6 Advanced EHF launches. And, anytime you're at Cape Canaveral, it seems, especially nowadays, that there's launches going off pretty regularly. So I've gotten to view launches both on console, on headset, going down the countdown script, like I believe Greg and CJ and Alan will be doing for EDL, to just being a casual spectator and feeling the power of the launch. It's something you can't quite explain to somebody who hasn't seen it.
Cool. Excellent. Let's go on to the next slide. And here, Gregory, can you tell us a little bit about this, but also in terms of what the coolest part about Mars, what you're learning or what you've learned or what you've done that's really the coolest thing to you as well? And did you get to, by any chance, go to the launch for Mars 2020, or given everything going on?
So surprisingly, since I've been working at JPL for 12 years, the Perseverance launch was my first launch I attended in person. So I was very fortunate enough to do that. And the benefits of being a NASA employee is getting on base. So our group of people were literally about a mile away from the rocket with a straight line of sight. And it was quite an amazing experience, because I remember just seeing like a small bright light in the distance. And then it just got brighter and brighter within a second or two. And then you saw this stream of smoke from the rocket. And within 5 or 10 seconds, you felt it. And that was my first launch experience. And it was just unbelievable. So I'm very glad I made it to Florida for that experience. In terms of something cool, that's coincidentally what this picture is. So for those of you who are wondering what's behind me, that is a parachute that we would use or would have used on Mars. this is actually me helping out with the InSight testing. So InSight was another spacecraft that landed on Mars in 2018, but we're testing this parachute in the world's largest wind tunnel. So just imagine a really, really big warehouse with ginormous fans blowing, wind really, really strong. And we're testing that the parachute can kind of the performance of the parachute and seeing it going through like high speeds. So this was really cool because, one, I get to test Mars parachutes in the world's largest wind tunnel, right? But at the time, I was just kind of helping the InSight project because I was working at the same time on Perseverance. But the cool thing is because I got to work on InSight for a few months, the year or two later, when we were testing our much larger parachute on Perseverance, they asked me if I wanted to run that test campaign. So really a highlight of my career on Perseverance was spending one whole year working with the team at NASA Ames at the wind tunnel, the NFAC, our parachute vendors, our parachute experts at JPL. And we spent the whole year planning this parachute test campaign. We spent 2 months installing all the hardware in the wind tunnel. And then we spent a few weeks actually testing these parachutes in the wind tunnel. So it's a really cool experience. And it's really like the picture doesn't do it justice, but when you're in there, it's just a really, really big place. And just to see the parachute inflate is it really brings things into perspective.
Awesome. Thank you, Gregory. That's wonderful. Okay, next slide. And CJ, tell us a little bit more about what the coolest thing related to Mars that you've done is. Have you seen many launches? And then somebody here has a question for you asking for a little bit more information about the EDL and the helicopter and synchronizing it for Perseverance and all of that. So let's start with the first part though.
Sure, happy to start. So the coolest part for me is, well, it gets, I got to tell you, so I've worked at JPL since 2014. I started as an intern after going back to school to get my degree. I was a 33-year-old intern. So starting as an intern was pretty cool, getting to have a new career later in life. And I got to say, each day, each month, each year, it just gets cooler. So the picture you're seeing here was taken in the last few months. We're doing our last tests to make sure that we, the humans, are ready for Perseverance to land on Mars. So this picture was taken in our cruise mission ops center. So this is where we are watching the telemetry coming down from the spacecraft and where we command it when we can. And what you'll see actually on landing day, this is where we'll be sitting. And this was really a highlight moment for me. It's a culmination of many, many years of hard work. I have been testing the Perseverance rover in our test bed for many years. I feel like Percy and I are old friends and we know each other very well. So to get to be there on the day that she's going to touch down on Mars is very, very exciting. And so this picture really represents that moment for me. To answer the question about EDL and the helicopter, the simple answer is the helicopter doesn't have anything to do with entry, descent, landing. We are sending a helicopter along with this mission, and the helicopter's installed on the underside of the Perseverance rover. It's actually attached to the belly with its own cover on top of it to protect it from when we're landing. So when we lower the rover down onto Mars, that helicopter's right there underneath the rover, so we needed to protect it. And our colleague Richard did a lot of studies making sure that the type of rocks we could see wouldn't damage it and things like that. But that's really the only relationship EDL has to the helicopter, is making sure that we could put it down safely, and once we're on the surface, that helicopter can be deployed and take its first flight.
Thank you so much, CJ. And we'll talk more about the helicopter in a little bit, I think. So Alan, we've got a nice picture here of Jezero. Can you tell us a little bit about what the most exciting part of what your work has been with Mars? Let's go back. Yeah. And also, how many launches have you seen? And then after that, I've got another question, a couple questions more about the climate on Mars that I wanted to hit you with. So.
Okay, fine. Yeah. For launches, I've been at sort of 1.5. I was there for the MSL launch, and I've been working with the mission ever since. The half was the Pathfinder launch, which it was delayed a couple days, and we just had to go home the day before it actually launched. So we watched it on TV in a hotel room in Tallahassee. So that's the half. And of course, the Perseverance, the Mars 2020 launch, we all watched on TV and wished that we could actually be there. So that's what I also saw a space shuttle launch long ago, where we live in Houston. It's right next to Johnson Space Center, and many of the astronauts live in the vicinity. And while our kids were young, we were friends with one of the astronaut families, and they gave us tickets to go to the launch. So we got to sit in the VIP stand for one of the shuttle launches. So that's my experience with launches. Really cool. If you get a chance, do it. What I wanted to show here is just a little bit of about the geology of Jezero Crater. And what you've got there on the left is a perspective view of the area where we're landing. It's a delta. There's a stream channel that comes out of the highlands from upper left of the frame down toward the center. And the area in the middle is sediment that was deposited by that stream into a lake that was in Jezero Crater. And so that's really what we're going to be looking at, is looking primarily for signs of life, rocks that might contain signs of life around the lake. And the first stop, where the green line starts there in the bottom left of the field, will be on the bottom of the lake, deposits from the bottom of the lake where maybe fine-grained muds and organics have been collected. And we'll take that green path wandering up through the delta deposits, and then eventually into the highlands beyond. And what I wanted to show on the right side there, the funny butterfly bow tie shaped picture with the colors, is some orbital data from the CRISM instrument that shows where carbonate minerals are along the delta. They're on this bench partway up the side of the crater.
And Alan, could you tell us what carbonate minerals are?
Oh, okay. Carbonate minerals would be like calcite, they'd be like limestone. That would be what we're looking at. Thank you, Christine. And the cool thing, at least on Earth, about these carbonate minerals, these limestones, is that most of them involve a life in some way or other. So that's one of the things we'll be looking at, is trying to look at those limestone deposits along the side of the crater. Possibly that they are formed by life, but on the other hand, they're also a really good way to preserve bits of life. And if any of you have ever gone fossil hunting, looked for fossils, many of them come in limestones, and so they're a great way of preserving signs of life.
Thank you. We've had some questions asking some more about temperatures on Mars and about the climate and the weather. And I just wanted to see if you had any follow-ups on maybe on how the climate of Mars has changed over time, given what we're seeing right now here. And you're talking about water, and when we know that Mars is really, really cold right now.
Yeah, exactly. Mars now is really cold. Like I said, the likely high temperatures during a year are around freezing. Someone in the chat in the questions had asked what the highest temperature was, and I believe the highest temperature ever measured was around 25 Celsius, which is like 70, 75 Fahrenheit, sort of room temperature. And that was, I think, on Viking 1 back in the 70s. In Gale Crater, which is near Mars, where MSL is right now, the temperature's really never gotten more than a few degrees above the freezing of water. But obviously, in Gale Crater, we're going through rocks that were deposited by a lake, and here in Jezero, this was delta was deposited into a lake. There was liquid water once. The estimate is that early Mars was warm enough to have that, and by around 3.8 or so, 3.7 or so billion years ago, its climate changed enormously and went from probably sort of a cool and wet place like Jezero Delta is showing us here to a much drier climate, much like what we've got now. And it's been pretty dry and cold ever since then.
Thank you. Thank you, Alan. All right, Michelle, let's go on to the next slide. And I believe it's time for another poll question. So let's go ahead and ask, let's see, which one should we ask now? Question number, question number 3. Let's start off with, how big is Mars? And we're going to give everyone about 5 seconds to answer your best guess. How big is Mars? Not everybody knows how big Mars is. So is it about a quarter, just a quarter as wide as the Earth? Is it about a whole third as wide as the Earth? Is it about the same size as the Earth? Or is it 1.5 times wider than the Earth? Going to give you 5, 4, 3, 2, 1. And what did everybody pick? A lot of you got the answer right. It's about a third as wide as the Earth, so it's smaller than the Earth. And some of the questions have been about gravity on Mars. One of the questions that we received was about how gravity on Mars might affect the drone operation, for instance. And that helicopter. I wanted to see if any of our panelists want to jump in and talk a little bit about that. Does anyone want to talk about the gravity on Mars and how that might affect the Perseverance helicopter?
I could probably
Gregory?
take a stab at that.
Thank you. Yes.
So first of all, I'm not a helicopter expert, but what I do know that in addition to the gravity on Mars, something that's also very different is the atmosphere on Mars. So it's much, much thinner than what we have on Earth. And atmosphere is very important for vehicles like helicopters. So in order to create Ingenuity, the helicopter, the team needed to have much larger wings and be rotating these, these propellers really, really fast to be able to get off the ground. I'm sure that gravity on Mars is less on Earth than it is on Earth. So I'm sure that helps out with the aerodynamics, but it's really more, a larger factor is the atmosphere being thinner than that on Earth.
Thank you. Does anyone want to add anything to that? I think the part of the reason that the atmosphere on Mars is thinner has something to do with the fact that the gravity is less. Yes, Alan, since Mars has less gravity, has the lower gravity on Mars been a factor in why Mars has less atmosphere now?
Yeah, that's a part of it. Of course, yeah, if the gravity is lower, when atoms get real high in the atmosphere, they can just fly away easier. What's thought to be more important really is that Mars doesn't have a magnetic field. And the Earth has a really strong magnetic field, and it looks like Mars had a pretty strong one once. There are some rocks on the surface that are pretty strongly magnetized. And what the magnetic field does is it keeps the sun's solar wind away from the atmosphere. And the solar wind is energetic particles that come off of the sun, and they hit stuff in the upper atmosphere of Mars and just blast it off into space. And that's probably where most of Mars's atmosphere went.
Okay. Thank you. Thank you. While we're still here, let's do poll number 7. There's a question here about the goals or the mission of the Mars 2020 mission, what its primary mission is. And so let's see what everyone knows about that. So let's bring up poll number 7 on the goals for Mars 2020. What will the Perseverance rover and the Ingenuity helicopter do on Mars? And everyone can select multiple answers here. Which of these things do you think that the rover and the helicopter are going to do while they're there on Mars? We're going to give you 6 seconds to finish answering this. 5, 4, 3, 2, and 1. Let's see what everybody voted on. Yes, so they voted that we would be studying the geology of Mars, that we would be looking for signs of ancient life. A few of you said maybe creating a breathable atmosphere. I don't think it's going to be doing that. A lot of you said that it would be collecting samples from Mars rocks and soil. A couple of you voted for planting a garden of potatoes. I don't think that's going to happen either. And a lot of you did vote for study the weather and climate of Mars or test technologies for future missions. So great. Those are some of the key missions of Mars 2020. CJ, do you want to talk anything about what we know about what the Mars 2020 mission is doing or what it's going to do?
Sure, Christine, I'd be happy to. I think the folks who answered we'll be creating breathable oxygen or breathable atmosphere weren't too far off. We have a new technology on board that we're testing. It's called MOXIE. And it's going to be ingesting the Martian atmosphere into the body of the rover, and will be trying to turn that into breathable oxygen. Now, obviously, the rover doesn't need oxygen to breathe, but this is a technology demonstration so that when we do send astronauts to Mars, we'll be able to create oxygen for them to breathe while we're there on the planet. It's very difficult to ship oxygen from Earth all the way to Mars, especially all of the oxygen our astronauts would need. The other thing that oxygen is really good for is fuel. So being able to turn the Martian atmosphere into usable oxygen also gives us the opportunity to create fuel for the return flight back to Earth. So that's one of the really awesome new science instruments that we have on Perseverance.
Thank you, CJ. Appreciate that. Let's move on to the next slide here. And Gregory, you gave us a picture here of
Yes.
of some equipment. Can you tell us a little bit more about this, and maybe a little bit more about how you work, and you know, a few details about what it is you do, how you got started on your career, the most interesting aspects of what you do on a day-to-day basis.
Okay, wow. That's a lot of questions, but I'll
It
try to
is.
give it a shot.
You don't have to do all of them. Pick one.
Okay. So this picture, coincidentally, follows. Can you go back to the last slide? So what you see here is what we call the descent stage, or a better way to think about it is it's the jetpack that's on the rover that we use for landing. So if you go back to my picture, so this is the descent stage, but back in 2014, when it was just kind of a skeleton without all of the propellant tanks and all the other lines and all the thrusters. So I was fortunate enough to go into the clean room at JPL, and really, Perseverance was kind of what's called a build to print mission. And so we used a lot of stuff from Curiosity. So it's kind of like recycling parts from Curiosity. And one of those things was this descent stage structure. So that's me inside of that. I just wanted to go into the clean room and check out the hardware that was going to be sent to Mars, and actually maybe touch it and pet it a little bit to say that I've touched something that is going to Mars. And so that's what this picture is here. And you can get a sense of scale, right? The rover is kind of car-sized, and the jetpack that it's attached to it is about the same size as well. So it's a really, really, it's bigger than a few humans here. So my job over the past 7.5 years is I've been part of the EDL systems engineering team. So CJ and I are on this team, and really it spans a wide variety of jobs, right? In systems engineering, one's job is to kind of learn a little about everything and piece things together. And so in this case, there are people who build the rover itself. There are the mechanical engineers. There are software engineers who build the flight software. And our jobs, people like CJ and myself, is kind of putting the whole system together, right? So when the mechanical engineers put their hardware and the software engineers put together the flight software together into a functioning spacecraft, CJ and I kind of take that and test it at the system level. So a fully functioning spacecraft. There are a lot of things I love about JPL, and as a typical systems engineer, I have a spreadsheet of what I love there. But one of the most important things to me are the people I work with. And it's just always inspiring, people like CJ, people like all my team members I work with every day, they inspire me on how brilliant they are, but also how down to earth they are, right? We're just all, normal, cool people, nerds working on this space missions, and we get to learn from each other. And in addition to that, we're really we've grown to become, I think, like a family. And so we're all always there for each other, whether it's work related or not work related. And that's something I really, really appreciate about working on Perseverance and at JPL.
Thank you. Thank you. Let's go on to the next slide here. And Ari, you shared this picture with us, and so we wanted to, is that Mars that you're showing there to Vice President Pence? Can you tell us more about the picture and about the coolest aspect of your job and what you needed to do to get ready for your job?
Certainly, yeah. So when I started at Lockheed Martin, I knew that space would take me to Southern California, to Vandenberg, to Denver, to Florida, DC, take me around the country. Never in a million years did I think that space would take me to the White House. And this particular picture was actually the last advanced CHF satellite that I talked about previously. And it was the first launch under the newly formed United States Space Force. As many of you know, the previous administration did recreate the National Space Council, and so we knew we had some really senior level supporters of our missions, of our overall space missions. And this was an opportunity where Vice President Pence surprised me and the other folks who were there and came into the West Wing of the White House and signed a flight blanket. It's an MLI, multi-layer insulation. And as kind of a funny anecdote, I had to hand carry this blanket. It's flight hardware, right? So you have to be careful the way that you handle this flight hardware. And I carried it in a big poster tube. And for those of you who are not necessarily familiar with multi-layer insulation, it's about 7 layers of material to help keep different parts of the vehicle warm. And it also has grounding wires coming off of it. So I had this blanket rolled up in a poster tube, and I traveling through San Francisco International Airport, put it through on the conveyor belt. And the TSA agent kind of stops on it, going through the X-ray, and then it comes through. And as I was picking it up, they go, "What's in there? Is that some sort of poster or something?" And I go, "No, it's a flight blanket for a satellite." And they go, "Oh, cool." So then contrast that to the security at the White House. I had to go through the same thing at the White House. And they made me open up the poster tube and pull out the blanket and did an examination of the grounding wire, making sure it was nothing dangerous. But really a fun experience.
Awesome. So I think that Michelle may have had an issue and has dropped off, but we're going to continue. So no problems there. I have a number of questions for folks, and Gregory, I'm going to go to you first. There was a question somebody posted about what the material is made out of from the parachutes. Do you know what they made the materials from the parachutes out of? Is it like silkworm threads, spider threads, Kevlar? Do you know? And if not you, does anyone else know? I don't know.
I do know. What I don't know is if I'm allowed to say what that is.
Oh, okay.
So
sorry. The answer is redacted. There is an answer, but is there anything more that you want to say about the topic?
Okay, I just quickly looked up. There is a paper that is published, so I will say.
Okay. So you are.
So I will say that. So the parachute is mostly nylon and polyester. So that's what most of the canopy is made out of.
Okay, thank you.
Yes.
And there was a question about the rover possibly burning up. Ari, do you want to talk a little bit about the heat shield that you mentioned earlier, and how that protects things on the mission from burning up in the atmosphere? Or
Yeah, certainly. So as I mentioned previously, we provided the aeroshell, which comprises of the back shell. That's the structure that Gregory was talking about earlier and showing in the clean room, and then the heat shield, which is on the front of the cruise stage. And so the way that we, as a collective team, keep the Perseverance rover and Ingenuity helicopter safe during what is referred to as the 7 minutes of terror. Although I'm sure if you ask CJ or Gregory, or Alan, it's more like, several hours of terror. But the way we keep the hardware safe as it descends and eventually makes its way to the surface of Mars is with that heat shield. I'm sure many folks have seen the famous video of the space shuttle tiles thermal protection system, where somebody has their hand and then the space shuttle tile, and then there's a blowtorch on the other hand. So you can kind of put those things together, and that's how we keep the hardware safe as for EDL.
Awesome. Thank you. There's a question here I don't know if any of you might have the answer to. Back during the launch, right before the launch, does NASA use a checklist before launching missions, planetary missions? This is there's a student who's studying to be a pilot who wants to know whether missions also use a checklist before launch.
Christine, I'm happy to take that one.
Thank you,
I would
CJ.
say, yes, we absolutely do. Our checklists are in the form of what we call procedures. And we use those not just at launch, but really before we do any major activity. As Gregory alluded
Definitely
to.
enterprise business owners, because enterprise means
Sherelle,
they have different
Sherelle?
avenues or.
Thank you. Sorry, I don't think she intended for that to be unmuted.
I'm
CJ,
muted.
please continue.
Working
Sorry.
with another vehicle. That's okay. Yes, so as Gregory was mentioning, our system is quite complex. And so as systems engineers, we're thinking about the whole thing, but we want to talk to the experts to know that their system is also ready for something like launch. So we're polling the thermal team, the power team, the communications team, and they're running through their checklist to make sure each of their subsystems is go, as we say, if they're go for launch or go for landing. And as you listen to landing on the 18th, you'll also hear us go through many checklists as we reach different milestones, as we get closer and closer to the atmosphere. So it's very important. That's the way we have come up with organizing ourselves. And those procedures are scrutinized and made months in advance and reviewed by many, many teams. So checklists are very important and close to all of our hearts as engineers.
Okay, critical role. Thank you, CJ. Alan, there's a question here about how our what's our current understanding of how long we think water was flowing on Mars? How long do we think water was flowing on Mars? You're on mute. Alan, you're on mute.
Excuse me. I just wanted to add a bit to what CJ said, that we have that same idea of checklists on surface operations too. Every day, every instrument, every operation has checklists, flight rules we need to check every single time to make sure we're not doing something stupid or putting the rover in danger. The question was water. How long was liquid water present on Mars?
Yeah, how long was it flowing on Mars?
Flowing. Well, we're pretty sure there's been no liquid. Well, okay, that's sort of a difficult question, because there's evidence from very early in Mars's history, like before about 3.7 billion years ago, that there was liquid water very common on the surface of Mars. This is where Jezero crater is with the delta in it, and Gale crater where the MSL rover is now. Those are very old deposits. Again, more than about 3.7 billion. And it seems that liquid water was fairly common across the surface of Mars then. Since then, it's only very, very rarely there has been liquid water. And I was just thinking that from the Valles Marineris, the big canyon on Mars, there's some huge outflow channels where immense floods came out of the canyons and flowed up north into the plains. And the Pathfinder rover landed on one of those. If any of you remember, can go back and look at those times. Those appear to be just absolutely catastrophic floods, but very short duration, and only occasionally, maybe around 1 or 1.5 billion years ago. So pretty much the answer is Mars had liquid water up until around 3.7 or so billion, and then only occasionally since then, catastrophic events. So, it's not just a one-word answer, but Mars is a complicated place.
So it had water, and then it didn't have as much, but it occasionally did.
Yeah, just occasionally. There's a lot of a lot of water, when you say water, you're meaning liquid water. There's a lot
Yes.
of ice in the subsurface, and that's where these big floods come from. So there's no liquid water at the surface now, but there's lots of ice at the poles and then a lot of ice underground.
Okay, awesome. Thank you. Oh, lots more questions. Let's go through a couple more of these, and then Michelle, if you wouldn't mind starting the PowerPoint again, that would be awesome. Let's see, Gregory, the photo that you shared of the system that you were touching, it had some clear panels. Can you tell us what the panels are made out of?
Clear panels. Let's see if I can go back to that picture. I think maybe the picture is referring to all of like the silver structure on the. I actually don't know exactly what that material is, so I would be. I'd probably be remiss to say anything.
Let's go to slide 20 here. Yeah, and we'll take a look at it and see. That one right there. Let's go back one. That
There.
one. They're not clear. Are they clear? They're semi-translucent, right? Those things on the sides, those flaps on the sides.
So no, they're not clear. I think that's just the reflection of the light and other things from the other side, but they're not clear. Yes.
Okay.
Unfortunately, I wouldn't be able to tell you exactly what that material is because I don't know.
Okay. Okay, but they're not clear. They're metallic. They're reflecting the bars that we see in the front.
That's right. That's right. That's right.
Got it. Got it. Okay. And CJ, there's a question here about Moxie. It's that you were talking about. Lisa asked whether is the Moxie instrument that you were describing, it'll be creating oxygen for breathable capacities and fuel for the rocket support system. Do you want to confirm, deny, add?
No, I would clarify that to say this is a technology demonstration, so that we hope to use that technology in the future when we send astronauts. But like I said, Moxie is hoping to ingest the Martian atmosphere and turn it into oxygen that could either be using for breathing support for future astronauts or for fuel. However, we're not containing the oxygen we're making with this instrument. This is something we'll vent back into the atmosphere just as part of this test.
Thank you. So it's a test. We're not planning on actually having it keep running.
Yeah, Percy doesn't need it to breathe, so we'll just send it back.
No.
I was thinking about this last night, and I think maybe a nice analogy is, on Earth, we breathe in oxygen and we exhale carbon dioxide. And so Percy will be doing the opposite of that, right? Mostly breathing in carbon dioxide and exhaling oxygen.
Cool. In much smaller amounts. But yeah. And Joe had a question while all of you are talking here that I think is going to have multiple answers. It's an interesting one. Knowing that scientists and engineers set different priorities on a mission, how are decisions made for what is going to be done during a mission?
I'm happy to take that, Christine.
Thank you.
That's a wonderful question, and you hit on the crux of what is a continuous discussion between engineers and scientists. There's no one decision point. In fact, we have a special office in the project that just deals with the communication between scientists and engineers, because you're right, we have very different priorities. If it were up to the landing team where we put Perseverance down, it would not have been the Jezero crater. We would have gone somewhere that was flat and didn't have a lot of rocks and basically looked like just a really big parking lot. But that wouldn't be very interesting for a science perspective. And so we had to change what we were doing and learn how to make new technology that could allow us to land in what we would consider unsafe places, but to a scientist is rich and awesome and has a lot of really cool things. So we're constantly balancing that. That starts at the very beginning of the mission when we get our instructions from NASA. And it really, that conversation continues all the way through, even after we're on the surface, when we're trying to decide where we're going to drive to. Scientists are part of every decision to make sure that we're balancing out the engineer's desire to always stay safe.
Thank you, CJ. Thank you. And Alan, you chuckled. Do you want to add any, or somebody else want to add something?
Yeah, I can add in a little bit onto that from the science perspective. It's a continual tug of war between the engineering and the science communities. It's never been antagonistic that I've seen, but they have their concerns are different. The engineers' concerns are different from the science concerns, and at least on the MSL mission, the typical procedure would be the science group would say, "Hey, we would like to go here and do something," and we will ask the engineers, "Is that possible?" And they will, go back and consider whether it's safe enough, and we'll say, "Yes, we can do it. No, we can't do it," or we have to, how much energy, how much time, how much data volume it will take to do that. And so there's always this trade-off about what can be done safely, because we don't want to do anything that's going to compromise the safety of the mission. I mean, we can't repair it. If something breaks, we cannot fix it. So we're always very, very careful about that. Yeah, there's something else I wanted to say there, but it continues all the way through the mission. And we've found that the engineering community is just incredibly sensitive and responsive to what the science community would like to do, and are amazingly creative. On the MSL mission, for instance, our drill system broke several years ago now. One of the actuators just failed. And the engineering community took what was available, what was left on the mission, and were able to come up with a new drilling scheme, completely unexpected from the beginning, but to take the parts they had and be able to satisfy the science desires to drill samples. So we're just immensely grateful for the engineering community for how well they can support the science goals of the mission.
Thank you, Alan. Anyone, Gregory, did you want to add in something?
Oh, I just wanted to go back. I actually phoned a friend, one of my mechanical engineer friends. And so he did inform me that these panels that you see are mostly aluminum.
Awesome.
Okay.
Thank you. Lightweight. Yeah, perfect.
Right.
Let's go on. The next slide, I think we've already talked a little bit about. Let's go on to the slide after that. Alan, this is one of yours, and you want to talk a little bit about this, and maybe a little bit also while you're talking about it, about teamwork and the role that teamwork plays in your work.
Okay. Christine asked me to pick up some slides that were sort of from my past and related to our mission here. One of the big ways that we try to understand Mars as scientists is looking for terrestrial analogs, places on Earth that are enough like what we think Mars is like, that we think we can learn from them and help guide our mission on Mars. And another part of our effort, of course, is education. And so this slide is from a teacher training workshop that we at the LPI did in 2005, I think it was. And we went to Mono Lake. You might ask people how many of them have been to Mono Lake. It's in Eastern California. It's a wonderful, wonderful place. And so that's our bunch of teachers there standing, being photographed. There I am. I weighed a little bit more then than I do now. Tori Holer was one of our guides, up the tall guy in the back in the center there. And Mono Lake is a really wonderful place just to go visit. It's got these gorgeous towers of carbonate minerals that we talked about before. And it is an analog to what, in some ways, to what the Jezero crater might have been. I mentioned that there are these carbonate rich, these limestone deposits along the rim of the lake. That's exactly what's happened at Mono Lake. That these carbonate towers here and deposits down in front are along the edge of the lake and not in the center. And so this may well be in some way an analog to what we will be seeing on Mars in Jezero. As far as teamwork, well, this is not so much, the training here was not so much a team exercise, but everything we do on Mars for all the missions is just incredibly complicated and interwoven teamwork. I mean, the folks on this call have very different aspects of the mission, and there are people of comparable levels of sophistication and knowledge for pretty much every part, every component, every plan that goes into the mission. So when we, talk about a rover mission on Mars, we're really talking about hundreds of people, maybe up to 500 people, all working in concert toward a single goal. And it's just an awesome example of how so many people can work together towards a common goal.
Thank you, Alan. Thank you. And Gregory, for the next image, I'm going to ask you the same question about team. Actually, it's CJ, right? Yeah. CJ,
yes,
teamwork.
CJ.
Teamwork. Tell us a little bit more about what it's like working with a team of people and what it's like right now working with a team, given everything that's going on.
Yeah, thanks, Christine. That's a great question. And that's why I wanted to include this photo, actually. So what you see here, this is the entry, descent, and landing team at JPL. We have team members spread across the NASA mission centers across the country. But the bulk of us are at JPL, and this is us all crowded in our boss, Al's office. Every year we get together and when we were still able to work in person, we did a lot of celebrating of anything we could celebrate, big holidays, small holidays. It was how we stayed connected. And we always made a holiday card to send out to the rest of the project. But to me, this just represents that kind of family feeling that Gregory alluded to earlier. We spend a lot of time together. We work very long hours. We work many days, weekends, and we've been together for years. So we've really got to know each other. And so not only do we support each other at work, we also, support each other in our personal lives. We have, yoga classes together to make sure we're not getting too stressed out. We have dinner sometimes. And it's really what helps carry through the really stressful times. And I think having that foundation of teamwork is what's helped us weather the last year of working remotely. So just like everyone else in the world, even though we still have to land this rover on Mars, as you can see, I'm not at JPL. I'm doing it from my home as the rest of our team. But I think having those years together, that's really helped allow us to continue our work together seamlessly because we built that time together. But I will say the other great thing about really being in a close team is it allows you not just to have fun together, but this is a very challenging mission and you disagree. And I think one of the things I appreciate the most is being able to work in an environment where you have such great respect for the people you work with that you can also disagree and from there really learn and push the design forward by being able to bring all ideas to the table. So those are some of the benefits to me for teamwork. It also just makes it a whole lot of fun.
Awesome.
Yeah.
Thank you.
And
Gregory.
If I can add a little bit,
Please.
Seeing this picture makes me a little sad because again, we're in the pandemic years. But in addition to these holiday cards, we did, every Halloween we had a team costume. So we had one year we did Shark Week, another week we did a play on rocks, different kind of forms of rocks like doing the Rock Johnson or a rock climber. But a really cool thing I think people might not even appreciate is that we also pull pranks on each other. So whenever people would go on long vacations, we would fill our colleague Mallory, when she left, we filled her entire cubicle with balloons. And then another thing that we did was maybe a little more wasteful, but we covered one of our office mates, Adam, his whole office in foil. And CJ did an amazing job with attention to detail because that's right.
That took 2 weeks.
CJ was even wrapping like the smallest pins individually with foil, and the attention to detail was amazing. But,
that's what happened
everyone
if you went on a multi-week vacation on our team. So you had to be
right when everyone else is working really hard, right? But yeah, taking vacation is important, but be prepared for a prank when you get back.
Awesome. So it sounds like y'all have lots of fun. That's wonderful. Let's go to the next slide and a poll question. Let's poll all of our attendees here. Let's use poll number 6 about assets on Mars 2020. So there were several questions asking us about things like the helicopter. What are some of the parts of the Mars 2020 Perseverance mission? And we're going to give everybody 5 seconds to finish voting. 4 seconds to finish voting. 3, 2, and 1. And let's go ahead and let's see what everybody voted. And a rover, absolutely, the Perseverance rover and the helicopter delivery system, that the Ingenuity helicopter. Not everybody is as familiar with the orbiting spacecraft or an aeroshell. And then human habitat, I put that one in there for fun. There's a lot of people who sometimes see things on TV that confuse us in terms of what's going on right now. And one of our questions that people submitted, there was a question about, for instance, how long could a person survive on Mars with supplies? Does anyone here have an opinion? I don't think we have a definitive answer yet, right? And I first misread it. I thought it said without supplies, and the answer is like, no, you couldn't, but with supplies.
Yeah, I don't think we've been able to figure that out. This is CJ. I don't think we've been able to figure that out yet, Christine, and we're still a ways from sending astronauts to Mars. I did want to speak, though, if I may, about we haven't actually talked yet about how we get to Mars and what are all the pieces that we've needed to get there, to get to landing. So if I may, I wouldn't mind taking just a minute to describe that.
Sure.
And actually, this picture is the perfect picture to do it. When we launch from Cape Canaveral on the rocket, we launch, and once we come out of the nose cone, the way in which we cruise all the way to Mars, you can see these two pieces of spacecraft here. They're actually separating. The first there on the left, that's our cruise stage. That has solar panels facing the sun. That's how it gets energy, and it's got propulsion that helps make small turns on the way to Mars. And that's attached to the aeroshell that you see just to the right of it. When we get about an hour from entry into the atmosphere, we actually jettison that cruise stage. We don't need it. We made it to Mars. And we continue into the Martian atmosphere with that capsule, the one that Lockheed Martin did such a great job creating for us. Inside of that, so that capsule, the part that you're seeing, the white side, that's the back shell. That's the part that at the very top is where eventually a parachute cone, our parachute will come out of. It's also got some antennas that are pointing to Earth that allows us to talk to the engineers on the ground. On the other side of that back shell, facing toward Mars in this picture, is our heat shield. And so together, those form a nice tight seal around the descent stage and the rover. And that allows us, when we come into the atmosphere of Mars, even though it's a thinner atmosphere than Earth, it's just enough atmosphere that we still have to deal with it. And so we come in going very fast, and we hit the top of that atmosphere, and we're going to burn up all around that heat shield. And that heat shield is what allows us to protect what's inside of that capsule from catching on fire. And once we've gotten into the atmosphere, our parachute will open from the top of that back shell and slow us down even further. Once we've slowed down enough, we will then jettison both the back shell and the heat shield. We don't need it anymore. And that's when we come out in the jetpack design that Gregory alluded to. So we've got a descent stage that's wrapped on top of the rover, and the rover has been folded up kind of like origami and tucked under the descent stage. The descent stage is firing its retro rockets as it's going down, trying to slow it down even further. And then when we get just above the surface of Mars, we lower down the rover on bridles that are coming from the descent stage. So kind of like a spider using its web, we just lower down the rover onto Mars. And once the descent stage has sensed that those wheels are on the ground, it cuts those bridles and it flies away and crashes in a really safe distance. So that's just a high level of kind of what we're doing. We've alluded to it a few times, but I thought it would be really helpful to describe the full process.
Absolutely. And what aspect of that is the quote 7 minutes of terror that people talk about, CJ?
That's a great question. The 7 minutes of terror starts once we've officially entered the atmosphere of the entry into space.
Okay, awesome. Let's move ahead 2 slides, Michelle, not to the next slide, but to the slide afterwards where Ari has some pictures around some of this. Alan, we'll come back to yours, but Ari, I want to let you speak to some of this as well when we're talking about the heat shield and the parts and where they fit together and all of that.
Thanks. So CJ just did a great job of explaining a couple of the pictures here. You see in the upper right-hand corner, the back shell in the foreground and the heat shield in the background, and those two elements make up the aeroshell. What a lot of folks maybe don't realize about the Mars 2020 mission is that we also have orbiting assets that are going to be a part of the entry, descent, and landing, and the entire mission, really, for that matter. So upper left there is the Mars Odyssey spacecraft that was launched in 2001. So 19 years strong, 20 years strong here for that spacecraft. It mostly supports the InSight lander, which is a previous JPL mission. But it can also support Mars 2020 as well as a data relay. In the middle there is the Mars Reconnaissance Orbiter. That's another Lockheed Martin built spacecraft that's been orbiting Mars and has been taking some incredible high definition pictures with its main payload, its main instrument called HiRISE. HiRISE was actually used to help determine the landing site for Perseverance in Jezero Canyon. So that's one of the ways it's supporting it. It also, we're going to try and capture pictures of the EDL itself. So while Mars 2020 and Perseverance and Ingenuity are making their way through the Martian atmosphere, MRO is tasked with trying to take some pictures. In addition, we recently uploaded a flight software patch to MRO that helps with the quick turnaround of telemetry, so that JPL and the entire teams have the ability to know whether we're successful or not a lot sooner than otherwise. And then finally there on the bottom left is the MAVEN spacecraft that Lockheed Martin built. And that's the Mars Atmosphere and Volatile Evolution spacecraft. That changed orbits in 2019 in order to help support 2020 as a data relay. And it will be communicating with Perseverance anywhere between 6 and 7 times per day as it orbits Mars. So a lot goes into the Perseverance mission, and there on the bottom right, we also have the Ingenuity helicopter delivery system. What's really cool about that, there was the question earlier about Mars atmosphere and how that impacts the helicopter. The thin atmosphere really, or the atmosphere really makes it difficult to get enough lift on the helicopter so that it can actually fly. And for that reason, it needs to be super lightweight. So the delivery system that Lockheed Martin built had to be compact enough to tuck the helicopter underneath the belly of the Perseverance rover and not add any additional mass to it. So a lot of cool technologies and a lot of, as Alan was talking about earlier, just some incredible engineering in order to make this whole mission happen.
And the helicopter, boy, that gives us a sense of scale, how small it is. Someone asked, is it true, and Ari, I don't know if you might know this or if somebody else might know it, that Ingenuity is only planned to make 5 flights. Does anyone know more about that?
I think that's correct. I'll let the other panelists comment as well. The cool thing about, as Alan was talking about earlier, in terms of engineers' abilities to kind of come up with new ideas and help the scientists get the data they want. A lot of times we're able to extend our missions. And so if we have 5 successful flights and we can keep on going, we're going to keep on going. So that's the plan there.
Thank you. Thank you.
What limits the helicopter to 5 flights? Is it power?
I believe it's power. I'm not 100% sure. Gregory or CJ.
I don't know enough about the helicopter system or its operation. So,
and someone asked about the purpose of the helicopter. Does anyone want to speak a little bit more about that? About its intent as a technological test?
I'll just say at a high level, right? We're landing on a planet, right? On a small area, Jezero Canyon of Mars. And so if you could imagine, wherever you live, if a spacecraft, a robotic exploration spacecraft were to land where you live, ask yourself, is where I live representative of the rest of planet Earth, right? And so what the helicopter allows the team to do is really get more science and a larger picture of the area where Perseverance is landing. My perspective.
Yeah, I think that's right. I think in part this is a tech demo, the helicopter, but it would be really nice for the science operations to have a much better view of where we're going, to get it like a drone's view of like a neighborhood or something on Earth. So you can really see what's going on ahead of you. And so it's not a huge surprise going over the hill. So whether there's a rock or a sand patch or something in the way. So I think for me, the hope is that something like this helicopter could be on every future mission and be able to help the rover be efficient in where it drives, how it gets there, and how to most efficiently use its resources.
Absolutely. Absolutely. We're running out of time. I'd like to move ahead 2 slides to Gregory's image here that shows a whole bunch of different things. And while the slide is up, I would like to invite all of our panelists. We have a number of students across the US and maybe even some around the world that are watching. Are there things about your when you were a student, what did you study? What did you like? What prepared you? And what do you wish somebody would have told you back when you were in middle school or high school? So I wanted to let each of you, and Gregory, I'm going to start with you. This is your slide, but sure. I'm going to talk about yourself and your pathway and your career, but also, what it was like to prepare for this.
Right. So I think the slide naturally answers that question, and that's it's kind of a cliche, but I think one of the most important things is to do something you love. And as you can see in this picture, I got really, really lucky, right? When I started out in college, I was doing accounting pre-law. And after 2 years, I had to sit down with my uncle and my mom, and they said, Gregory, you're a smart guy. You don't have to necessarily do what you've been told, what you should be doing, whether it's a doctor or lawyer. And after 2 years of college, I decided to make a switch into something I actually like to do. And so throughout school, I was really good at math and I loved science. And because of that, I said, okay, well, let me just drop my last 2 years of college and start all over again in physics. And one thing led to another. I got a NASA scholarship during my junior year, which led into a job at JPL. And within my first year, I got to work on Curiosity. And so the collage you see, most of that is me working on Curiosity for a year or two back in 2011 or 2013. And it was just an amazing experience because I was new to JPL and I was able to kind of do a little about a lot of different things. And, after that amazing experience with Curiosity, I said, hey, I saw the EDL team and they're really cool. Like, I want to do that. And so I basically bugged the EDL team on Perseverance for a long time. And fortunately, a position opened up and Al Chen called me and said, hey, do you want to come onto the team? And since 2013, I've been working on that team. One more thing I want to share with everyone is, I think a very important lesson I've learned in the past decade or so is that it's okay to fail. And in fact, a lot of great learning opportunities come from failure. And I've had numerous of those experiences throughout JPL and even in college, right? I like to share the fact that in college, I actually got an F in one of my math classes. It was during a really rough time in my life, but I got that F, but what was important is that I came out of that and I learned from that experience and I redeemed myself afterwards and continued to progress. And the same lessons can be applied at work, right? When there's a failure, you kind of take a step back and understand, like, why did that happen? And make sure you understand how that will not happen again. And you try again, right? So in closing, it's okay to fail as long as you try in the first place. And more importantly, when you fail, you get back up and continue going.
Thank you, Gregory. Who would like to go next? Alan, your mic is on. Yeah.
Okay, I can go. And let me be a typical student. What was the question, please?
What sorts of classes did you take to prepare for your career? And if you were still what would you tell your younger self? What do you wish somebody would have told you back when you were a student?
Oh, Well, I wish someone would have told me to pay attention to what I really wanted to do first, rather than do what other people thought. Yeah, I guess, like he was saying, I went to college doing a lot of what my parents had thought I might want to do, and for me, the change came. I was in math and didn't do very well in math, and then I went to physics and had trouble there, and ended up in chemistry. And in my junior year, I took PChem, and the first PChem test, I didn't do well on it. I finished like 2.5 of the 10 questions on it. I went back to my room and crawled in bed and went under the covers and thought, what the hell am I going to do with the rest of my life? And thought back to how I really enjoyed rock hunting and fossil hunting and all as a kid. And by the time I came out from the covers, I decided that's what I wanted to do, which is where I should have been all along. And as it turned out, I hadn't done any worse than anyone else on that test, but that was enough to change me. For other people, for everybody, I think, in addition to your topic, whatever subject you want to learn, probably the best additional thing you can learn is how to write, how to communicate, because everything we do in our field, everything we do in sciences and engineering hinges on communication with other people. And if you can't communicate your ideas to other people, they are lost. So that's what I would recommend to everybody. Maybe not creative writing classes, but just how to use English as a language, or whatever your host language is, and how to get your ideas across clearly. Because if you can't do that, you'll never make an impact in the world.
Thank you, Alan.
I'll hop in real quick, Christine. And I think to answer the question of what I wish somebody would have told my college self, I spent a lot of time thinking about what I really wanted to do, and stressing over the fact that I wasn't quite sure what I wanted to do or what I wanted to be when I grew up. I think that if somebody would have told me, you know what, learn how to learn, and learn how to communicate, like Alan was saying, learn how to use your different resources, and then you'll figure it out. You have an opportunity within industry to do multiple different things. I've had 9 different roles in 18 years at Lockheed Martin. So you don't have to know exactly what you want to do when you're in school. You can figure that out along the way.
Thank you, Ari. CJ, you get the last word here.
Yes, I mean, I'd echo a lot of what my peers said. I agree that communication is incredibly important. That kind of was considered a soft skill when you're in engineering school, but especially as systems engineers, that's so important to learn how to talk to people. But I would say the number one thing that I would have wanted to tell my younger self, and to tell the young students that are listening today, is that success doesn't always come in a straight line. That struggling to learn something or to fail and start again is not actually a sign of failure. That's just part of the process. When I was young, school came very easy to me until I got to college, and then it got harder. And I thought that was a sign that I wasn't very good at what I was doing. But the truth is that when you try new things, it takes a little while to learn about those new things and adjust and try new ways of doing things. And so I think it's really good to start to get comfortable with being uncomfortable when you don't know something, because at that point you're right at the precipice of a breakthrough, and so just hang in there and keep going. So that would be the one thing I'd add.
Thank you, CJ. There's a number of questions that we're not going to have time to get to. I thought we would, but there were just so many great questions. What we'll try to do is we'll try to keep track of all these questions and maybe answer them on that YouTube page that we posted, or on the USRA STEM Center site. I will ask Amanda now to share further, and let's continue here past. Yeah. Oh, I want to, LPI has some things too. If people want to look at some of our events coming up, please go to LPI's website and learn more about some of our public events. But the next slide, I will let Amanda take over here.
Thank you, Christine. So in closing today, we just again like to thank our panelists for this incredible experience, as well as Lockheed Martin that generously provided support for today's event. Finally, don't forget to check our website for updates on upcoming educational activities that I mentioned earlier today, and like us on Facebook. Also, please don't forget to submit responses to our brief survey, which will appear momentarily. So that's it from me, Christine.
Thank you.
For joining us today.
Yeah, we have a poll question. It'll be really quick and it'll take everybody about 10 seconds to do. Thank you all again so much. And we're going to give everyone who's answering our poll questions 15 seconds to answer them. You've got 15 seconds to answer these 3 questions. Are you more interested in STEM after participating today? Have you learned something by participating today? And would you like to participate in something like this in the future? So we're going to give you 15 seconds, 14, 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, and 1. Thank you all so much for your information. We really, really appreciate it. And thank you again to our panelists. Thank you, Amanda. Thank you to Lockheed. Thank you, Michelle, for all the work that you've done putting this together. And yay, everyone, join us in saying thank you to our panelists. And bye-bye now.
Bye, everyone.
Goodbye.
Bye. Thank you.
Thanks.